So we are group 12, and my name is Olga Taylor.
Hello everyone, my name is Chiebuka Okoro.
And today we're presenting our project dedicated to text-to-speech using Hugging Face. Next slide, please. So text-to-speech, or TTS, technology is rapidly transforming how we interact with digital content. It converts written text into spoken words using AI, making information more accessible, especially for individuals with vision impairments, reading challenges, or busy lifestyles. TTS is used in everything from smart assistants and customer service bots to e-learning tools and public service announcements. It's especially valuable for supporting multitasking, enhancing comprehension, and reducing screen fatigue. Next slide, please. Some of the key benefits, we definitely can see that the impact of TTS spans across industries. It automates voiceovers for videos and educational content, builds voice interfaces for smart devices, and helps localize content in multiple languages. It's cost-effective alternative to voice actors, especially useful when content is frequently updated. For students and professionals, TTS improves productivity through listening-based editing and learning. These benefits make it an essential tool for creating more inclusive and efficient digital experience. Next slide. So, how text-to-speech works? TTS converts written text into natural-sounding speech using AI and deep learning. The deep learning models help the system understand how words relate to sound, allowing it to replicate pitch, tone, and rhythm naturally. This makes AI-generated voices sound much more human-like and expressive, enhancing the listening experience. The two core stages in the process are linguistic analysis and speech synthesis. So first, the model analyzes the structure and the meaning of the input text. It looks at grammar, punctuation, and even expands abbreviations. The synthetic phase, it converts the processed text into audio. It starts by creating a spectrogram to map sound frequencies over time, and finally, a voice encoding network can turn the time-aligned features into audio waveforms, which computers can convert into natural sounding speech. Some advanced models even let users adjust speed, pitch, and also choose between different languages and accents. Next slide. Of course, there are some ethical considerations. One of them can be voice cloning, so synthetic voices can replicate real individuals, useful for accessibility, but risky for impersonation and deepfakes and fraud. Misinformation and manipulations. TTS can generate convincing fake content, spreading false news and emotional messages for political and commercial influence. Some privacy concerns. So it requires access to voice data, raising questions about consent, data protection, and misuse of biometric information. And finally, bias and fairness. TTS models may reflect and reinforce societal biases like accent, gender, race, leading to exclusion or misrepresentation. Some other challenges and limitations. First, the audio quality can be inconsistent. TTS systems often mispronounce rare technical terms, and the clarity of the speech may vary depending on the language or voice selected. Second, these systems struggle to express emotion unlike a human speaker. A TTS voice has hard time conveying sarcasm, excitement, empathy, which can affect how the message is received. Third, listening to a robotic voice for extended periods can be tiring and make it harder for listeners to stay engaged. And lastly, personalization is limited. While some settings can be adjusted, achieving a specific tone or delivery styles is much more difficult compared to using a real voice actor. Next slide. So to address these challenges of text-to-speech technology, there are several practical strategies we can implement. First, for mispronunciation, we can use custom dictionaries of phonetic spelling to ensure the correct pronunciation of technical and uncommon words. To improve emotional expression, new AI models are being trained on more natural, expressive speech, which helps make TTS voice sound more human. We can also adjust voice parameters, things like pitch, speed, or pauses, to make the speech more dynamic and easier to listen to. Offering a variety of voice options can help users choose a tone that best fits their content, whether it's for education, entertainment, or professional use. And finally, For content that requires emotional depth or strong human touch, combining TTS with professional voiceovers remains a reliable solution. By applying these strategies, we can significantly improve the user experience and effectiveness of TTS systems. Next slide. So one of the example of voice generators is Amazon Polly. It is a fully managed service that generates voice on demand, converting any text to an audio stream. Using deep learning technologies to convert articles, web pages, PDF documents, and other text to speech, Polly provides dozens of lifelike voices across a broad set of languages for you to build speech-activated applications that engage and convert. Next slide. Some of the benefits that Polly offers, it's a high quality voice output that sounds natural and engaging, creating a professional and immersive customer experience. It supports a wide range of languages and accents, making it ideal for reaching global audiences and enhancing content accessibility. Polly integrates seamlessly with other AWS services like Amazon S3 or EC2, streamlining of workflows and simplifying deployment. Its user-friendly interface allows for easy text input, voice selection, and customization. Business benefit from consistent voice quality across platforms, which helps maintain a cohesive brand identity. Additionally, Polly offers dozens of lifelike voices in a wide range of languages, allowing you to build speech-enabled applications that engage users and drive conversions. Common use cases for Amazon Polly include, but are not limited to, mobile applications such as newsreaders, games, e-learning platforms, and the rapidly growing segment of Internet of Things. Next slide. And finally, we're going to talk about Hugging Face for TTS. When it comes to experimenting with or building TTS systems, Hugging Face is a powerful platform. It hosts a wide range of pre-trained models like ESP.NET TTS or Coqui TTS, enabling developers and researchers to quickly prototype and deploy voice applications. The collaborative model hub also allows for shared learning and innovation, making it go-to resource for anyone working on speech-based projects or looking to integrate natural-sounding voice into their products. And now I'm going to hand over to my colleague Chiebuka for a demonstration.
Thank you very much, Olga. I really appreciate your explanations. So we're going to move on to the demo. With respect to the demo, so we are going to be using a Google model that helps to like basically get inputs and then processes it to try to analyze the language, and then you tell it, okay, this is the language I want to like process this stuff in, and then it converts it to the language and speaks it out to you. So basically, so these are the libraries and the modules. This is where we are importing them. So I'm going to run this first. We're not going to do anything too heavy or intensive because of time purposes. But we are going to try to like test majority of the functions of this model and this program. So let's wait for this to run. Okay. So after installing um all the necessary libraries that need to be installed, then we like imported the various libraries modules within those libraries that we need. So what we are going to do now is to go ahead and try to like run the program. So we are going to do it in two forms. The first one is using a document, and the first one is actually imputing text, and the second one is trying to like convert text to speech from a document. So once we run this, so the first thing is, how would you like to provide your text? So our text, we want to provide it like just by typing it in or pasting it from somewhere. So I'm just gonna use one, and then I'm gonna like check up on Olga here today. So I'll say hello Olga. So it asks me enter the number of your preferred language. So what language do I want to use? In this case, I'm going to use Spanish, which is number 14, and I click it in, and then it asks me if is my current language is it already in Spanish. I say no, and then it converts it for me. So I'm going to play this now so you can hear how it converted it from English to Spanish.
Hola Olga, confía en que lo estés bien hoy.
So in the second phase of this demo, what we are going to be using a document to try to see if this program can actually access the document and try to like read out the transcript for us. So what I got here, I got a Spanish website. So what I'm going to do now, I'm going to copy this and I'm going to paste it. This is so long, but I'll just take the shorter version. So let's see how many paragraphs this is. This is the first paragraph, and this is the second paragraph. So I'll just take the first few paragraphs and then see how it goes. Okay. So I'll copy this. I'll open up a new Word document. And then bring this here. Can you see the Word document? Okay, so I paste this in here and then I save it as a PDF. I save it as Rebel TTS. So once I publish that, I close this and then I close this as well, then save. Okay, so we're going to run this again, but this time around we are going to be uploading a file, and the file is going to be in Spanish and want it to convert it to English. So hopefully it's going to read this to us. I don't expect it to read it like better or exactly how it is, because like Olga said during the presentation, these models still have a long way to go in making them very perfect. So run this time around, we are uploading a file. So it asks us to choose the file. So I'm going to go to documents, I'll do Rebel TTS and then open it up. So once it's done, it's asking what is the preferred language. So we want it to read it out in English so we can compare it with what we have here on the other side. So English is 13. Is it already in English? No. Okay, so let's wait for it to generate. Okay, so it's done generating the speech. So we'll go ahead and listen to the speech now.
Without Sleep by Federico Garcia Lorca. No one sleeps for heaven. No one, nobody, no one sleeps. The creatures of the moon smell and are around their cabins. Live iguanas will come to bite men who do not dream, and he who flees with a broken heart will find for the corners to the incredible still crocodile under the tender protest of the stars. No one sleeps around the world. No one, nobody, no one sleeps. There is a dead man in the farthest cemetery who complains 3 years because it has a dry landscape in the knee. And the boy who buried this morning cried so much that there was a need to call dogs to shut up. Life is not dream. Alert, alert, alert. We fall down the stairs to eat the wet earth, or we climb to the edge of the snow with the choir of dead dahlias. But there is no forgetfulness or sleep. Living meat. Kisses tie the mouths in a tangle of recent veins, and who hurts his pain will hurt him without rest, and who fears death will take her on her shoulders.
So that concludes our presentation, and like you heard it, it's not as perfect as we humans can be, but it's something that definitely can be worked on to make it better. So thank you very much for listening to myself and Olga today, and do enjoy the rest of your day.